J is a centroid, so we're looking at number 9 from our homework. J is a centroid. When we do have a centroid, that means it's the exact center of where all the vertices meet, and we're working within medians. Since we're working within medians, that means DG is congruent to EG, EH is congruent to HF, and then we have FI is congruent to ID. Okay, next we have the following lengths given. We have DH is 51, we have GF is 60, and EI is 57. Due to constraints of how much room we do have in it, I'm going to use the highlighter to focus on how to get the answer. So DH is that length right there, 51. Then we have GF, which is 60, which is this length right here. Then lastly, we have EI, which is this length right here. So we have the following. 51 is for DH, for GF it's 60, and then EI is 57. Alright, so the first thing we need to look at is that we have DJ. So DJ is the distance from the vertice to the centroid. That means it's about 2/3 the length of what DH is. So to set this one up, we need to do the following. DJ is equal to 2/3 of 51. So 51, remember, comes from this length, the entire length. So you can use your calculator. You could do 51. You could do 51 times 2, and then just divide it by 3. You get the length of DJ is going to be 34. So now we're working in the realm of JH. JH is the other length between it. So DJ, JH. So we know that the entire length of DH is going to be 51. So the way we're going to do this one to find JH is we're going to use the line segment addition postulate. What we're going to state is that DJ plus JH is equal to the entire length of DH. We're going to plug in the information we know to solve for the missing length. DJ is 34. We got it from that. JH is what we're solving for, so plus JH is equal to DH, which we're given at 51. So to solve for this one, we just got to isolate JH to figure out the length of it. Subtract 34, subtract 34, 51 minus 34 will give you a length of 17. So that means JH has to be the length of 17. Okay, so the next part is we're looking at GJ. We're looking for GJ. We're looking for GJ. Well, this is going to be the exact opposite of what we did for letter A. So the way we're going to find that is we're going to use, instead of 2/3, we're going to use 1/3. The way we're going to find that is GJ is equal to 1/3 of GF, which is 60. This is just another way of writing 60 divided by 3. 60 divided by 3 should be 20. So we get this is equal to 20. Now it's looking for JF. Well, we got 20 here. We can use the line segment addition postulate again. We can say that JF plus JF plus GJ is equal to GF. We know the lengths of GF. GF is going to be 60, is equal to GJ, which is 20, plus JF. Do a little subtraction, you get JF is equal to 40. Alright, and so now we're looking at the last part. We're looking for EJ. So this one I'm going to approach a little different, just so we can kind of see what's going on here. So the way we're going to do that is, give me 1 second. Alright, so what we have here is we're looking for EJ. EJ is representing for EI. So we know EI is 57, and we know the length of EJ is 2/3. So the way we're going to solve this one is do the following information. We're going to say that EJ is 2/3. So the way we can look at it is EJ is equal to 2/3 of EI, which is going to be 57. Again, you can use your calculator to solve this one. You could do 57 times 2 divided by 3 and get you about 18.3 repeating, which is fine to have this decimal for this one. Again, you could do 57 times 2, and then divided by 3. Oh, it's actually 38. So again, 57 times 2 divided by 3 gets you 38. And lastly, we want to find JI. Let's do this one a little differently than we have been. So we know the length of JI is 1/3 of the entire length. So we can say that JI is equal to 1/3 of the entire length, which is 57. And this one, 1/3 is the same as dividing by 3, so you could just say 57 divided by 3 gets you 19. So JI is equal to 19. Okay, that's the various ways you can solve for the different line segments.